Good morning, dear students. Let's begin our lecture. The term of our lecture is Introduction of Computer Systems and Architecture of Computer Systems. Today we must talk about computer systems. How do you think? What is it, computer systems? Which plan we can say about computer systems? At first, I want to introduce you of plan of lecture. First, architecture of computer systems. Second, types of computers. And the third, the basic components of a computer systems. So, I think that all of you know the architecture of computer. Yes, but we can't talk about inside of computer, and nowadays now we talk about architecture of computer systems. A computer architecture is a detailed specification of a computational, communication, and data storage elements of a computer systems, how those components interact, and how they are controlled. Computer architecture includes the following areas. First, the fundamental physical components that constitute a computer system. The kind of instructions, language the computer can understand. Then the third, the underlying computer technology that manipulates these instructions, sometimes referred to as microarchitecture. The architecture of a computer is a description of its organization and the principles of functioning of its structural elements. It's a computer main device and communication in between. The principles formulated in 1945 by John von Neumann are the basis for creation of the majority of a computer. This picture, you can see in this picture, architecture of computer systems. First, it is our input device. Here, for input device, we can say our keyboards, our printers, and all of these devices which we can input our informations. Then, after input device, all of these informations services central processing unit. It's a control unit and the arithmetic logic unit. And after here, we can choose memory unit. After then, we have output devices. For output devices, we can say our monitors, our then also monitors, then all other devices. All of this structure, this picture, we call the von Neumann or store program architecture. The illustration above shows the essential features of the von Neumann or storage program architecture. Computers based on the storage program concept or the von Neumann architecture store or their program code and the date that is required for the computation in the computer's memory. During computation, program instructions are retrieved from the memory and executed one after the other. The component in a computer that controls this computation is known as the central processing unit. It's called CPU, or nowadays often just referred to as a processor. First, the main unit is called memory unit. The computer will have memory that can code for data and also the program processing that data. In modern computers, this memory is RAM. RAM is mean random access memory. And the input-output. This architecture allows for the idea that a person needs to interact with the machine. Reservoir values that are passed to and further stored once again in some internal registers. Now let's talk about the types of computers. The first type is a personal computer. The personal computer is a small and here only single user computer based on a microprocessor. Only single user. In addition to the microprocessor, a personal computer has a keyboard for entering data, a monitor for displaying information, and a storage device for saving data. This computer is called personal computer. Then the next one is a workstation. Workstation, how do you think which computers we can call workstation? Workstation is a powerful, here used only single user computer. A workstation is like a personal computer, but it has more powerful microprocessor and a higher quality monitor. Then next one is our mini computer. Mini computer is used a multi-user computer capable of supporting from 10 to hundreds of users at the same time. Then the next one is our mainframe. The mainframe is a powerful multi-user computer capable of supporting many hundreds or thousands of users at the same time. Here can use many hundreds or thousands of users. And the next one is our supercomputer. It's here an extremely fast computer that can perform hundreds of millions of instructions per second. Only millions of instructions per second. Then here we can look, we can see the types of computers. Notebooks, desktop computers, tablet computers, and handheld devices, our personal computers, and mini computers, mainframes, supercomputers. I think nowadays we use our notebooks, tablets, and desktop computers, yes? Mini computers. Mini computers is a typically supported hundreds of users. It's not longer a product line. And mini computers is a smaller and less expensive than mainframes. The real difference is relative in terms of price, power marketing, and known as mid-range computers. In this picture, we can see the computer systems and the system unit. It's our processor, our monitor, our printer, keyboard, mouse, and our hitbox. All of this we call a computer systems. Here showed the output devices, input devices. For input device, we can say mouse and keyboard, and for output device, we can see our monitor, hitbox, and our printer. Now, let's talk about main components of a computer system. The main component, I think all of you know, the brain of the computer is our processor, yes? It's our processor. It's called CPU. It runs program instructions. Then the next one is our main memory. It's the storage for running programs and securing data. Then the next one is our secondary storage. It's a long-term program and data storage. For example, hard disk, CD, and etc. And the next one is our input device. It's a communication from the users to the computer. For example, our keyboard and the mouse. It's our input devices. Then the next one, it's our output devices. Communication from the computer to the user. For example, monitor, printer, and speakers. In this picture, you can see the basic components of computer. It's our CPU. First of all, we can talk about CPU. It's a control processor unit. Then monitor. Without monitor, we can see our informations. Then the keyboard. Without keyboard, we can't input our informations. And the speakers. Without speakers, we can't listen our voices. And the printer. Without printer, we can't print our information on a paper. And the modem. Now, without modem, we can't connect to the internet. And the network card. Without network card, we can't connect to the internet. And the floppy disk and CD-ROM. Without this floppy disk and CD-ROM, we can't translate our informations. And the last one, hard drive and RAM. Without hard drive, we can't save our informations. Without RAM, also we can save our informations. The CPU controls all of the other resources within the systems in order to accomplish a task. Central processing unit, it's consists arithmetic logic unit and the control unit and the registers. Arithmetic logic unit includes performs calculations and decisions. Control unit, it's a coordinates processing steps. And the registers, small, fast storage areas for instructions and data. Now I want to talk about characteristics of processor. It's a count. Word size equal to the number at the same time processed bits. The higher the bit processor, the more information it can handle per unit time, the above its effectiveness. Clock frequency, the number of operations performed per unit time. Address space, the maximum amount of memory which can serve processor. Represents set of addresses used in this computer system. And the next one is our memory. Computer memory, it's a millions, billions of on-off tabs. It's divided into bits. Bits include 0 or 1. And bytes. Bytes, it's a group of 8 bits. A byte is the smallest unit of storage. And the next one, words. Groups of bytes, 8, 16, 32, 40, 64 bits. The main memory characteristics. Very closely connected to the CPU. Contents are quickly and easily changed. Holds the programs and data that the processor is actively working with, and interacts with the processor millions of times per second. And the last one is nothing permanent is kept in main memory. The main device of PC. PC is called personal computer. The main device, at first we can say the keyboard. Then controller. The main device of PC is the ROM and RAM. RAM, random access memory, ROM, read-only memory. And the next one is our processor. RAM and ROM, it consists our highway. And processor, it consists our data bus, address bus, and control bus. From this system, from this line, we can see our keyboard, printer, display, and drive. System bus. What is it? System bus. System bus. It's a processor sets the address bus memory address which wants to read. We can see the translation in Russian of these words. One the control bus passes the processor read signal and the read signal. And then noticing the read signal, check all devices whether or not on the bus addresses of their address. And the RAM, nothing that exposes her address, reads the control signal. Memory read address. Memory bus exposes the requested information data. Then the last one is the memory part, the control read signal bus. And also a processor reads date from the date bus. Here, if you can't understand this term, we can read our translation in Russian. The internal memory of the computer. The internal memory of the computer, at first we can say RAM. RAM, it's a random access memory. It's located on the motherboard. It is used for temporary storage of data during the immediate PC and also provides recording modes, read, store information. And the next one is our ROM, read-only memory, used for permanent storage of data that don't require intervention. Here, program starts and stops the computer, testing devices, the control operation of the processor, display, keyboard, printer, external memory. It's intended for reading information. And the next one is our cache memory. It's a buffer memory unit. Internal memory cache located inside the processor. External cache memory located on the motherboard. It's used to increase the performance of your computer, matching operation of devices with different speeds, the exchange of data between processor and the memory.